Problem 30 out of the set of problems for reviewing for the final exam. Notice this one's also going to be a linear system problem, and we're given two different sets of information. We're told that there's a play going on, and they charge a certain amount per adult and a different amount for each senior citizen. But then they tell me two different things. They tell me that there was a weekend when they had a total of 476 people that were there. And on that weekend, the total receipts were $7,190. So let's see if we can build a system of linear equations that kind of covers this. And let's see, what have we got here? What are we looking for? We're looking for how many were senior citizens and how many were adults, right? So what we're trying to find is how many were adults and then how many were senior citizens. Okay, so let's let this be the number of adults will be X and the number of senior citizens will be Y. We'll substitute back when we get to the end of it. So what are we told now? Let's see what we're told here. All right, so we're told first some information about the money. We're told that if we knew how many adults there were, if we knew this is going to be the number of adults and the number of senior citizens, if we knew how many adults there were and we took $25 and multiplied that times the number of adults plus $10 times the number of senior citizens, we would get $7,190. That's one equation. The other equation is that on this particular night, if we knew the number of adults and we added it to the number of senior citizens, just the numbers, we would say that there were 476 people in attendance, right? So you'll notice that this equation tells me about the money, and this equation tells me about the number of people, but whatever value of X here and here, value of Y here and here must satisfy the two different equations. I mean, I could find a value of X and a value of Y, that two numbers that add up to 476. There's lots of combinations that would add together to give me 476. But with that combination, then when I replaced that X here and the Y, then I get $7,190. All right, so let's see if we can solve this. You ready? Just going to copy it down, leaving dollar signs off. We'll just use these as numbers. Now remember that the thought process with these linear systems is we're talking about equalities on both sides. In other words, this amount, this value, these values, whatever this is, equals that amount. These values equals that amount. So if I take an action here, I do the same action over here. This is just simple equation stuff. If you take some action on one side, you got to do the same on the other. Now, since this is equal to that, then when I combine these equations, I'm adding an equal amount to this side, which then is equal to this. So it looks like when I combine this side of X's and Y's with these X's and Y's, and then I turn around and add the numbers over here, it looks like I'm combining different things. But remember now, this side equals that, and this equals that. So it's adding equals to equals, if you think about it. So let's just find some way to eliminate, one of the variables. An easy way to do that might be to just do this. Let's just multiply this one by minus 10 and then combine them. So I'm going to say 25x plus 10y, 7,190, minus 10 here, minus 10x, minus 10y, and that's going to be a negative what? 4,760. Okay. Now I'm going to add these together, and remember again, this is okay because I've got something equal to this, something equal to this. So I'm going to add this equal to that. And so it's like adding equals to equals. 25 take away 10 leaves me 15x. These go away. I have no y's. And then it's just now a matter of, second quit, clear. So that's 7,190. Can you see that? No, you can't see that. 7,190 minus 4,760. Can you see that? Yep. And I get 2,430. So 15x is equal to 2,430. Should be easy now to find a test value for x by what? Divide both sides of this thing by 15. Divide by 15. And I get that x is equal to whatever 2,430 is divided by 15. And I get 162. Now, what do I conclude from that? Well, I conclude that, one possible solution would be that there's 162 adults. Well, if there's 162 adults, how many senior citizens were there? Well, you just substitute back. You say, well, if there was 162 of these and some number of the senior citizens, and you get this. And of course, this is a simple subtraction now, right? So it's going to be 476 minus 162, and that gives me 314. So I think that these are my numbers. 162 adults, 314 senior citizens. All right, if in fact this combination is the right combination, when I replace 162 here, 314 here, I should get $7,190. You want to try it and see? Let's try and see. So I'm going to say 25. You can't see that, can you? I'm going to see 25 times 162 plus 10 times 314. That should equal 7,190. Now remember, I kind of got this a little garbled up here. Remember now, this is the money, and this is the money, and these are the numbers, right? But let's see if that works. So I'm going to have what was that? That was 25 times 162. So that was 25 times 162 is equal to 4,050, and then 10 times 314 is equal to 3,140. And sure enough, when I add 3,140 plus 4050, I in fact get 7,190. So it checks. Well, that wasn't too hard, was it? So we plugged in, substituted the 162 for the number of adults, the 314 for the number of senior citizens, multiplied them times the prices, and we came up to the amount of money. And then we know that 314 and 162 added together give me 476. So what's the answer here? They wanted to know just how many senior citizens there were. And so we said that the number of senior citizens, okay, we call the adults. These were adults. And these were adults. And these were the senior citizens here. So 314. So the answer to 30 is B. The answer to 30 is B. I'll just slide this around here where you can see that work. You need to see it again.